In this video we're going to look at how p-values can be used to make decisions about correlation coefficients. Calculation of p-values for correlation coefficients is actually beyond the scope of this unit, but you may be given the value of a correlation coefficient for some data and asked to decide whether or not there is significant evidence that the correlation coefficient is greater than 0 or less than 0 or different from 0 from the appropriate p-value for the hypothesis under consideration. In other words, the question will give you the p-value for the hypothesis. So this means that if the given p-value is less than 0.01, then there is very strong evidence to reject the null hypothesis that there is no correlation in favour of the given alternative hypothesis. If the given p-value is between 0.01 and 0.05, then there is strong evidence to reject the null hypothesis that there is no correlation in favour of the given alternative hypothesis. But if the given p-value is greater than 0.05, then the data does not give significant evidence to reject the null hypothesis that ρ equals 0. So let's have a look at this in terms of an example. From a database of different laptops, a random sample of 22 laptops, each with hard drives of capacity 256 gigabytes, was taken, with the aim of discovering whether there is any correlation between the price and the weight of 256 gigabyte laptops. The correlation coefficient between the price and the weight of the sample of 22 laptops was calculated to be minus 0.378, and the associated p-value is 0.0828. By first writing down suitable hypotheses, determine whether there is strong evidence to support correlation between the price and the weight of these laptops. So we need first of all to define our variables, so we'll let ρ be the correlation coefficient between the price and weight of the population of all 256 gigabyte laptops. Our null hypothesis is going to be that ρ is 0, the correlation coefficient is 0, there is no relationship, no linear relationship between price and weight. Our alternative hypothesis is that there is a relationship, in other words that ρ is not equal to 0. Since the p-value is greater than 0.05, the data that we've been provided with gives us no evidence of correlation between the variables. There is no reason to reject the null hypothesis since the p-value is bigger than 0.05. So the sample gives us no evidence of correlation between the price and the weight of these laptops. The remaining examples in this video are going to use this table of results, which comes from an article entitled Storks Deliver Babies, written by Robert Matthews and appearing in a June 2000 issue of Teaching Statistics. First of all, we're going to determine whether the data provides evidence that there is correlation between a country's area and the number of stork pairs in the country. The correlation coefficient was calculated as 0.579 and the associated p-value is given as 0.0149. So, defining variables first, if we let ρ be the correlation coefficient between the area of a country and the number of stork pairs in that country, when we are considering all possible countries, then our null hypothesis is ρ is 0. Our alternative hypothesis is that ρ is not equal to 0. Looking at the data that we've been told, we've got a correlation coefficient of 0.579 and we're told that it's got a p-value of 0.0149. So the p-value is between 0.01 and 0.05. So the data provides us with strong evidence of a correlation between the area and the number of storks in a country. Looking at the scatter diagram for the areas of the country, different countries in the sample, and the number of stork pairs in the different countries in the sample, we obtain this graph. And this raises a couple of things for you to think about. First of all, have the outliers had an undue effect in reaching the conclusion? And secondly, is a sample consisting of just European countries appropriate for making decisions about the population consisting of all countries in the world? Another example now. Does the data provide strong evidence that for a population consisting of all European countries this time, so we're just considering European countries, there is positive correlation between a country's area and the human population of those countries? The correlation coefficient is 0.812 and has a p-value of 0.00038. So again, we need to define our variables. So we'll let ρ be the correlation coefficient between the area of a country and the human population of that country for the population consisting of all European countries. We now need to state the two hypotheses. The null hypothesis is that ρ is equal to 0. Now we're looking to see in this case whether there is evidence or strong evidence for there being a positive correlation between a country's area and its population. So our alternative hypothesis in this case needs to be that ρ is greater than 0, that there is positive correlation between the variables. The data from our sample of European countries gave us a correlation coefficient of 0.812 and a p-value of 0.000038. Now 0.000038 is much smaller than 0.01. So we can actually conclude that there is very strong evidence of positive correlation between the area and the human population of countries in Europe. If we look at our scatter diagram for the sample data that we had, you might like to think whether the scatter diagram confirms the conclusion that we've just made. Now to finish the video off, there are two questions here, again referring back to the data about European countries and the number of stork pairs in those countries and the population of those countries and the birth rate in those countries. There are two questions for you to answer here. So stop the video at this stage, answer these two questions, take your solutions along to your next lesson, and be willing to discuss them with your teachers and your fellow students. And this finishes our look at using p-values with the correlation coefficient.